Welcome to NASA Science Live. This is your chance to interact with NASA experts and have your questions answered in real time. I'm your host, Tahira Allen. Today, we're diving into the excitement surrounding the upcoming total solar eclipse that will cross North America, passing over Mexico, the United States, and Canada. If you have questions throughout the show, you can send them in using the hashtag AskNASA on social media or drop them directly into the comment box wherever you're watching. Now, this eclipse isn't just any ordinary celestial event. It is a rare opportunity for millions to witness the moon completely block out the sun, turning day into dusk for those in the path of totality. And get this will be the last total solar eclipse to cross the contiguous United States for the next 20 years. What makes this even more special is that an estimated 31.6 million people live within the path of totality. And if you're not in the path of totality, no worries. Everyone in the contiguous United States will have the chance to see at least a partial solar eclipse. Now picture this, a collective pause as people across the U.S. gaze upward to experience the wonder of the cosmos together. I can't wait. And today I'm joined by Dr. Gina DiBraccio, a sun expert who's going to walk us through how to prepare for the April 8th event. Gina, welcome.
Hi, Tahira. Thanks for having me.
And thank you so much for being here. Now, can you kick off by telling our viewers a little bit about your role here at NASA?
Sure. So I'm the Deputy Director of the Heliophysics Science Division at NASA's Goddard Space Flight Center. That means I'm helping to oversee an organization of scientists that are studying heliophysics, which is the study of the sun and its influence on everything. So we're looking at the physics of the sun, but also how it impacts the Earth's magnetic field, the upper atmosphere, and really just understanding how the whole system works together.
That is great. And Gina, I'm so happy to be here with you again today.
Yes.
Gina and I had a blast hosting last year's annular solar eclipse, and I think it's safe to say we are thrilled to be back again for the total solar eclipse. Now, before we dive into some details, Gina, can you help clear something up for me?
Sure.
What exactly sets an annular solar eclipse apart from a total solar eclipse like this year?
Okay. So when a solar eclipse happens, the moon is going to cross in between the Earth and the sun. And when that happens, the moon's shadow is cast on the Earth, and we can look up in the sky and see it. Now, for an annular eclipse, the moon is going to be just a little bit farther away so that it doesn't completely block out the sun. And that's what you can see on the screen here. You're left with a ring of fire in the sky. Cool. Now, for a total solar eclipse, the moon is going to be closer to the Earth so that the sun is completely blocked, and that way we can see the solar corona. It's that hot upper atmosphere of the sun that we can't see with our visible eyes on a day-to-day basis.
So it's really good to know that difference because, you know, it's my understanding that in total solar eclipse, the safety tips then are a little bit different than an annular.
Right, exactly.
And so for our viewers at home, we have a special guest, someone you might recognize, who's here to let us know how to safely view the April 8th event.
Hi, Eclipse enthusiasts. Lance Bass here, and I want to tell you how to protect those eyes and stay safe during a solar eclipse. During these celestial events, the sun, earth, and moon are in sync, creating solar eclipses. You can look directly at the sun during a total solar eclipse, but only when it's completely covered by the moon for a brief period known as totality. This is a really special moment. At all other times, you should wear eclipse glasses so that you don't say bye-bye-bye to your vision. Seriously. And eclipse glasses are not the same as regular sunglasses. No, they're not. Safe solar viewers are thousands of times darker and will have a specific certification that you should look for right here. Don't be a space cowboy and try to look directly at the sun. If you don't have eclipse glasses, you can use an indirect viewing method, like a pinhole projector. You can make one of these with something as simple as an index card with a hole, or a colander, or even your hands. With the sun at your back, you can safely project an image of the sun through the hole onto a nearby surface, like the ground. It's gonna be me who is wearing my eclipse glasses, and so are you.
Okay, we are already seeing a lot of questions pouring in online from our viewers watching, so let's jump right into this Q&A. Now remember, if you're watching live, you can submit your own questions for Gina using the hashtag AskNASA or by posting them in the comments wherever you're watching today. Alrighty, Gina, our first question is from... Oh, it actually looks like, so we've got kind of a group question here.
Okay.
It looks like a lot of people watching are asking about notices that may have been issued in certain areas with guidance on how to prepare for crowds and preventative measures meant to reduce traffic. Could you give us a little bit more info on how to best prepare for April 8th?
Sure. So as you said earlier, Tahira, along the path of totality, we have about 31 million people.
A lot of people, which is so cool to think about.
So it's already crowded to begin with. And of course, we'll have people traveling into that area to make it even more crowded. So, you know, just think of the preventative measures that you can take in case you get stuck in traffic. So make sure you have gas in the tank. Make sure if you have a battery operated car, you've charged up, you have some extra food and water with you. If there are traffic lines, you know, just be prepared to have patience and wait a little bit for that.
Thank you, Gina. And so we have our next question is from a user on Facebook who wants to know what science will be done during the total solar eclipse.
Right. One of the things that we're most excited for at NASA is actually performing different science experiments during the eclipse. Now, a favorite that I like to talk about is that we're using NASA's WB-57 high altitude research jet to perform some experiments. So the jet,
cool.
the jet's going to fly across the path of totality so that it gets a little bit longer in totality than if you were just standing on the ground. And what that means is that the instruments on board are going to look up at the solar corona and take images so that we can study the composition of the corona, understand how particles are accelerated and charged, and also be able to study dust that is around the sun that we can't really understand when we look at just on a day-to-day basis either.
And this is only an experiment that can be done during a total solar eclipse? Is that right?
Right. So we do have instruments called coronagraphs that are essentially artificial eclipses, and they will block out the sun so that we can study the corona. But the way that the light bends around these coronagraphs, we can't actually get deep down into the corona itself in that lower part of it. So for the total solar eclipse that happens naturally, it allows us to get down into the lower part of the corona, which means this is one of the only times that we can, you know, study this area of the sun.
That is amazing. And so we have our next question on Jordan, from Jordan on YouTube, who wants to know, why is it bad to view a solar eclipse directly?
Okay, thanks for that question, Jordan.
Yeah.
So we want to be really careful about eye safety during any eclipse or even on a day-to-day basis. You don't want to look at the sun so that you're not causing any permanent damage to your eyes. Now, the way that it works for a total solar eclipse is that during the partial phases, you need to have the proper safety viewing that we just heard about. You can have the eclipse viewing glasses, you can make a pinhole projector, and you need to use that to see the partial eclipse. If you're in the path of totality, during totality, you don't need to have those glasses. You can look directly up at the sky and see the sun because it will be blocked. So you're just looking at that corona. You're not actually going to be looking at the sun, but only for totality.
And I have a great follow-up from Mouse757 on YouTube who wants to know, where is the path of totality for this event?
Okay, you can go to the NASA website, go.nasa.gov/Eclipse Explorer, and it will show you the map so that you can actually see where totality is located. But across the U.S., it will stretch beginning down in Texas, all the way through Ohio. We'll have a station in Cleveland doing the broadcast too, and then up through Maine as well. Yeah, exactly.
And thank you for that. And then our next question is from Matthew Hinson on YouTube, who asks, what happens to the moon and the sun as seen from Earth?
During the eclipse, so we have the sun in the sky, and the moon will be crossing in front of the sun. So when you're looking up at the sky with your proper safety gear, what you'll see is that the sun slowly becomes covered by the moon. And that's our perspective from the surface of the Earth, basically, is that we're going to see the sun kind of disappear as the moon moves in front of it.
That is so cool, too, that the moon is just the right size, you know, to cover the sun
Yes.
during this event. And so we have Alana Franklin on YouTube who wants to know, how long will the eclipse last?
So if you're in the path of totality, maximum totality will be around 4.5 minutes long. It depends, though, where you even fall within that path. If you're on the edges, it could be a little shorter. You want to be kind of as deep within it as you can, and then you'll get that maximum totality. But I will say that this eclipse that we're having coming up in April, totality is lasting longer than it did in 2017 when we had the eclipse across America as well.
Do you know why?
So it just has to do with kind of where the moon is in its orbit, how far it is away from the sun. And for that one in 2017, maximum totality was only about 2 minutes, a little bit more than that. So we're almost doubled.
Like doubled. Oh man, that is so cool to know. So our next question is from a viewer on X who wants to know, what tips do you have of taking pictures of eclipses?
Okay, well, if you are taking pictures of eclipses during totality, you can use your phone. That's fine. The same way that we can look at the eclipse with our eyes during totality only, you can also use your phone to take pictures. Now, at any other part, you need to have a proper solar filter in order to take those photographs.
So not during a partial eclipse.
Correct.
Yeah, anytime. Okay. So our next question is from Ryan on YouTube who asks, when was the last eclipse and when is the next one?
Okay. It depends on how you define eclipse. So in this context, let's talk about total.
Okay.
Yep, total eclipses, total solar eclipse. So the last one that crossed through the U.S., as I just mentioned, was in 2017, and I was actually fortunate enough to see that myself. So I was really excited to see it. Yeah. So the next one coming up, though, isn't for another 20 years. Across the U.S. So you'll have to really, take advantage of this one unless you want to wait 20 years from now.
Yeah, absolutely. And so actually, this is one of my favorite questions. We have Wilbur on YouTube who wants to know, do animals react in a certain way? What are some of these changes that we can expect during a total solar eclipse?
Right. When the eclipse is taking place, it really gives that feeling of dusk, and nature reacts as if it is dusk. So if you have the opportunity to view the eclipse also in more of a quiet place where you can appreciate nature, you might be able to see the birds flying back into the trees to nest for the night, or you can hear the crickets come out and chirp and just kind of look around and watch nature, because it really does react to what's going on with the eclipse.
It is so cool to think about, too, that this is just like a multi-sensory experience for everybody.
Right.
And so our next question is another, I'd say, group question. We are getting a lot of questions about the timing of the eclipse in specific areas around the country. And, actually, luckily, NASA's got us covered with that, with an incredible tool to help with just this. As Gina mentioned earlier, it's called the Eclipse Explorer Map. And our friend James Trailey is back here, and he's going to walk us through how we're going to use this new map to prepare for April 8th.
Have you ever wondered how to track a solar eclipse down to the exact second? NASA has you covered for the April 8th, 2024 total solar eclipse that will be sweeping across North America. I'm James Trailey, and I'm going to walk you through how to use NASA's Eclipse Explorer, an interactive map designed to help you plan your eclipse viewing experience. This interactive map offers layers of detail that you can toggle on or off to explore each facet at your own pace. Start by visiting go.nasa.gov/Eclipse Explorer. Today, I'm showing you how to prepare for the April 8th total solar eclipse. So let's jump in. This is the map with the eclipse path. A menu should appear on the left, which you can expand or collapse with this little arrow that you see right here. With this menu, you can manipulate the map in a lot of ways. But I first want to show you how you can look up what the eclipse will look like in your location, and the timing of when you should look up, with proper eye protection, of course. I'm at NASA Goddard in Greenbelt, Maryland right now, so I'm going to type that into our zip code city bar and hit enter. And it will snap right to our location, Greenbelt, Maryland. And you'll notice when the map zoomed in, it displayed a box with information about what I will see and when in my location. You can click on the various phases of the eclipse with these little icons right here to see what the sun will look like at different points during the eclipse. The map also includes information about the current weather and cloud coverage, along with a countdown to the maximum eclipse and the percent of the sun that will be covered in your area. If you're located in the path of totality, where you have the chance to see the total solar eclipse, your information box will have a special feature when you click on the maximum eclipse. To demo that, let me go over to Cleveland, Ohio, which is in the path of totality, and snap that up here for you. So in the spot where we saw the percent of the sun covered in greenbelt, now instead there's the duration of totality, which for Cleveland is 3 minutes and 49 seconds. That's when the moon will completely block the sun. And when I click on the time of totality, and to be precise for Cleveland, it's 3:13:45 p.m., you see it snaps directly to what the sun's upper atmosphere, called the corona, will look like from Earth. A total solar eclipse is the only time we can see this faint region of the sun with our own eyes. The corona also holds clues for scientists about the sun's behavior and activity. Some other cool features include the ability to use the slider bar that you see right here to move the moon's shadow across the path of totality. You can see it sliding like that. On April 8th, when the eclipse is happening, you can select this live button that's right here, and it will track the eclipse in real time. By clicking the percent coverage that's right here, I can zoom out a little bit to show this, you can see just how much of the sun will be covered by the moon in any given area, even outside that path of totality. And remember, it is only safe to look directly at the sun without eye protection during totality. At all other times, including when the sun isn't blocked at all, and during a partial solar eclipse, you should wear eclipse glasses or view through an indirect method like a pinhole projector. For safety tips from NASA, visit go.nasa.gov/eclipse eyes safety. There are many more layers and features to dive into on the Eclipse Explorer map, so I encourage you to take a look to prepare before the total solar eclipse crosses North America on April 8th. And join me, along with other NASA science communicators and experts on April 8th, for the NASA broadcast starting at 1 p.m. Eastern Time. We'll be taking you with us as the eclipse moves across the country. Thank you, and enjoy the total solar eclipse.
Impressive, right? Now, you can access this map from the comfort of your own home and witness the eclipse journey in real time on April 8th by visiting go.nasa.gov/eclipse explorer. Now, Gina, this map is one way for folks at home to get involved in the eclipse, but I understand there are some other ways that people can play a true hands-on role in this April 8th event. Can you tell us a little bit more about those?
Right. We have different projects among NASA where the public can get involved in order to really contribute to our understanding of the eclipse and eclipse science. So 2 of those projects that I want to talk about, the first one is Globe Observer. And with Globe Observer, you download the app to your phone, you need a thermometer, and what you do is you actually take measurements before, during, and after the eclipse of the temperature where you are. You record it in the app. You also take pictures. It's very simple for people at home to do. You take pictures of cloud coverage as well, because what that's doing is it's reporting the conditions local to you so that we can understand what changes the sun is actually having on our atmosphere during the eclipse. So that's one of the projects where anybody in the public can get involved. Now, the other one is called Sun Sketcher. And this one, once again, requires an app from your phone that you download. And you're going to put your phone down and actually just let it take pictures during the eclipse. And what it will do is focus on the Bailey's beads that form. So that's kind of the light that you see peeking around the moon as it's covering the sun.
Oh, cool.
And those Bailey beads are the light coming through kind of the peaks and valleys on the moon, where it helps us to understand the size of the sun and the shape of the sun and really kind of what's going on there with the structure of the sun. And so with that one, again, just a simple app that you download, you leave your phone go, and it takes the measurements for you.
I mean, technology these days, you know, right? Like it just completely fascinates me that you can do NASA science from your cell phone. And if you're interested in learning more about these projects that Gina just mentioned, or other ways that you can do NASA science, visit go.nasa.gov/do eclipse science. Now, Gina, not only will we be able to witness a total solar eclipse on April 8th, I've heard that for those in the path of totality, you could also see some other things in the sky around that time.
Oh, that's right.
Could you tell us a little bit about what we could expect?
Sure. So we actually have the opportunity to see some planets out in the sky during totality, because when totality occurs, it's going to cover up the sun and it makes the sky darker. So we have the opportunity, as you see on the screen here, to see Jupiter, also Venus. Those are going to be 2 of the brightest planets in the sky. But then right along there, Mercury, Saturn, Mars, those are all faintly visible. And then even more exciting, there's a comet that can be visible too. That's Comet 12P. It's faint, but depending on, how dark your area is and whether you can see it in the sky, take a look and this will be an interesting planetary alignment.
Absolutely. And I mean, as if this day wasn't, rare, exciting enough. Now we've got this planetary alignment, we've got a comet.
Right.
And so fingers crossed on clear skies. Now we have some more questions coming in. Okay. Let's get to a few of them.
Sounds good.
All right. We have Twilight, linkable on YouTube, who asks, I heard that some eclipse glasses don't have the right specifications to protect your eyes properly. When shopping for glasses, what specifications do I need that will protect the eyes?
Sure. When you're buying those glasses, of course, you always want to get them from a credible source. One way to check is there's a standardized number. It's called the ISO. You want to look for number 123122. And I think we have some people from my NASA team here that can input that in the chat so that you can make sure that you're getting those glasses with the right safety specs as well.
Okay, great. Thank you. Thank you for that. And so our next question is from Antonio Rabid on YouTube, who asks, do we know what the weather will be like during the eclipse?
Right. So the weather will depend on whatever location you're in.
Okay.
Yeah. But we just heard about that Eclipse Explorer map, and that actually has real-time weather information in it where you go to your location and you can find out what the weather will be during the eclipse there.
I have I'd say a good follow-up to that. Halloween Hool 31 on YouTube asks, will temperature change during totality?
Oh, yes. So this is something that is one of the most fun things to experience. And we experienced this during the annular eclipse, too.
It completely blew my mind.
Right.
So.
We're shivering up on stage a little bit. Yeah, the temperature will drop. The sun is blocked and the energy, the heat coming from the sun into the atmosphere, it changes the atmosphere. And that's also why we have this Globe Observer public project that we were talking about to measure those temperature changes. So, there's different things that will affect how much the temperature will change. For instance, how humid it is in your location, but you will feel that temperature drop, and it can be as large as 10 to 15 degrees.
Yeah, I mean, even just for what we experienced with annular, like you said, I mean, we're like shivering on stage, and then for totality, what, we expect it to be even a little bit more?
Yeah, probably a little bit more than what we had for annular. But even for the annular eclipse, a majority of the sun was blocked. So, get chillier in both of those instances.
So I know we touched on this earlier, but for those of us who are just tuning in and watching, can you explain again what is the key difference between an annular solar eclipse and a total solar eclipse?
Right. And so basically a solar eclipse happens when the moon crosses in front of the Earth, in between the Earth and the sun. Now for annular eclipse, the moon will not be blocking the sun completely. It's going to leave a ring of fire because the moon is just a little bit farther from the Earth in this case. For the total solar eclipse, the moon will be slightly closer to the Earth, and it will block out the sun so that we can see that upper atmosphere of the sun, the corona, as the sun is obstructed during that totality. So the viewing here that you see on the screen, that's the main difference in the effects, whether you get to see the solar corona or if you're looking at the ring of fire in the sky.
And so we've been touching a lot about, the path of totality and being in totality for a total solar eclipse.
Sure.
And so we've got a few viewers who want to know, what if I'm not in the path of totality? What can I expect on April 8th?
Yeah, and it's just as exciting and spectacular if you're not in the path of totality. You won't get to see the corona because the sun won't be completely covered, but you'll still get to experience a partial eclipse. And depending on where you are, the amount of that partial eclipse will vary. You can go to the Eclipse Explorer map to see just what coverage you have. But viewing a partial eclipse is really exciting too, and you'll still get some of those temperature changes and the changes around you as well. So whether you're in totality or seeing that partial eclipse, it's still cool. Exciting. Yeah.
So we have Mayor Usman on YouTube who wants to know, is cell phone disruption expected? Will this affect any of our communications during the eclipse?
Oh, that's a great question. And so, there is space weather activity that can disrupt our cell phones when the sun is sending harmful radiation out into space. It can impact the Earth's upper atmosphere and cause minor blips in cell phone. However, first of all, we have different things in place to avoid that. And specifically during the eclipse, that's not really something that we have to be worried about. But I'm glad that people are thinking in that direction. That's great.
Yeah, and you mentioned studying space weather, things like that. We have another viewer who wants to know, what missions does NASA have that study the sun, and what mysteries are we hoping to solve?
Okay, well, right now, NASA, in the Heliophysics Science Division, we have the Parker Solar Probe mission. And this mission is actually flying into the upper atmosphere of the sun. So that solar corona that we're talking about viewing during the eclipse, Parker actually flies through it and touches it. And this is the first spacecraft to ever get this close to the sun. In fact, on December 24th of this year, it will have its closest approach, flying 9 solar radii close to the sun. And that might sound far, but it's actually the closest that a spacecraft has ever gotten, so that we can really figure out how the physics operates in this region.
Okay, now 9 solar radii. Can you give us an idea?
Oh, yeah. So I'm going to ask my team here to give us some stats on that and put it in the chat, just so we can get it maybe into miles for people to understand.
Yes, that would be great.
But it is much closer to the sun than we are, so that we can touch the atmosphere there.
Awesome. And so our next question actually, again, has to deal, with the sun and its activity. It's from Fox McCloud on YouTube, who wants to know, will we see solar flares during the eclipse?
That could very well happen. Now, the sun has an 11-year activity cycle where the activity is ramping up and down. And when it ramps up, we see more of those solar flares, we see coronal mass ejections, and more. And right now, we are gearing towards solar maximum, which means we have more of this solar activity happening, and you can see the explosive flares occurring. So if we were ever to see some of this activity during the eclipse, this would be the time, because we have tons of activity happening. So fingers crossed with your solar telescopes or your viewing, that we can see some solar flares erupting.
Is there any certain science we can only conduct during a total solar eclipse? This is another viewer on YouTube.
Okay. Right. So some of the experiments that we have going on with NASA are things that we can only do during the eclipse. One project that I'll talk about is looking at ham radio operations, and actually how the radio signals are impacted over the atmosphere. So the radio signals will be sent over the atmosphere, and during the eclipse, the atmosphere changes. And what we can do is have these ham radio operators send their signals to really understand the impacts of the sun on the upper atmosphere and how it might change those radio communications.
And my follow-up question, we have Mel on YouTube, who, going back to, some eclipse safety, wants to know, if we are not in the path of totality, do you still need to wear those eclipse glasses?
Yes. The short answer is yes.
Yes, 100%.
Especially if you're not in the path of totality.
Yes.
You always need to be using those viewing glasses, or kind of your at-home products like a colander that allows the sun's light to come through the holes. You can make your own pinhole projection. Something that's really easy, you can just take your hands and kind of weave them together to create your own holes. And you put them down towards the ground, you let the sun come through, and you look at the ground. That's one way to see the eclipse.
And what are you seeing on the ground then at that point?
You'll actually see what looks like the crescent suns that is the eclipse that's happening. So you'll see the partial eclipse being projected onto the ground.
And so my next question is from, okay, we have somebody that actually has a follow-up to our conversation earlier about the solar flares.
Okay.
So they want to know, are solar flares dangerous to us on Earth?
Great. Oh, this is a great question. So the Earth has a magnetic field that shields us from a lot of these, harmful radiation particles that come from the sun. Yeah. So for us, first of all, not every solar flare will be directed towards Earth. They're directed in all different directions towards different planets, or not even towards any planets at all. The ones that are directed towards Earth, really our magnetic field and our atmosphere works to shield us from a majority of those particles. Now, when we have astronauts in space, we do have different protective measures that we take to protect them. We work on predicting when these flares might take place, when they might arrive, and our astronauts have radiation covering that they can actually shield themselves if they need to.
And so I actually want to stay on that topic. That's a great follow-up. Well, I have a great follow-up to that topic. For someone who wants to know, how does the study of the sun I guess, heliophysicists,
Sure.
work with our efforts of sending humans into space to the moon, you know, and even farther into the solar system?
Right. Well, personally, some of the research that I do is on Mars and understanding how the sun impacts Mars. And we want to understand this because one day we're aiming to send humans to Mars. So we really need to understand how this radiation coming from the sun, or these solar flares that we're talking about, how they might impact the different planets. We can take data from different NASA missions that are studying these planets to really assess how the atmosphere or a planet's magnetic field might be impacted by particles coming from the sun. And then we create tools that we can use to protect our astronauts when they go to travel to other places such as the moon or Mars.
So another great follow-up. Inspector on YouTube wants to know, will the International Space Station be affected by this total solar eclipse then?
For astronauts that are on the space station during the eclipse, if it is kind of crossing over the U.S. region during the time of the eclipse, the astronauts are able to view it from a different vantage point. Now, they're looking down at the surface of the Earth, so they would see the moon's shadow moving across Earth. Yeah, so it's a different perspective than what we're seeing. You can see it on the screen there. That's from one of the previous eclipses. That's the moon's shadow actually being cast onto the surface of Earth. There you go, as seen from the space station. So that's a great view and a unique perspective to have.
That is. And it's really amazing that we are able to, you know, have photos from both the ground and space with the International Space Station.
Yep.
And Mary Hart on YouTube wants to know, for the total solar eclipse this year, does NASA plan to photograph it from the ground at all?
Yes. So actually, this is something where the public can once again get involved. As long as you have the proper solar filter and a telescope, you can take pictures of it. You know, during totality, as we said, you can use your phone to take pictures of it. It's safe during totality to use your phone to take pictures, photographs. We have amateur astronomers and whatnot as well. So these are ways that you don't have to be a NASA scientist to photograph it, as long as you know how to do it safely. And some of these images are just stunning to look at.
Absolutely. And I mean, this is another, you know, good reminder of the volunteer project that you mentioned earlier, Sun Sketcher.
Right.
To where you download an app, put your phone down, and you're able to photograph the eclipse, contribute to NASA science, and, you know, enjoy the moment.
Exactly.
In the present moment.
Yeah.
So, this is a good one. My next question is, what was it like for you to watch the annular solar eclipse last year?
Well, we were together.
I know. That's why I love this
stage.
question.
I will tell you, my experience with the annular eclipse was so much different than the 2017.
Was that your first
total
annular eclipse?
That was my first annular eclipse.
Okay, that's right.
Yeah.
Wow.
And I will say, you know, viewing it almost felt fake. It didn't seem real to see the moon kind of coming in front of the sun. Yeah, but on top of that, it was the crowd around us that I remember. I remember, you know, the minute before annularity, people were just so excited and cheering so loudly that it felt like this experience that we were all sharing together. And that was a lot of the fun to it too. You know, I think we were talking about how we got goosebumps during annularity.
It was really emotional. I was not expecting for it to
Right.
be so emotional. I mean, it was really just this perspective shift, right? To where you're like, wow, I'm on Earth and we're part of this larger system that's moving in the universe. And this will be my first total solar
that's
eclipse. So I'm
exciting.
glad that we get to experience this again together.
Yeah.
So our next question is from Bill Harvard on YouTube, who wants to know, will an eclipse like this happen again?
Right. We will have other total solar eclipses happen. The next one that will cross across the United States won't be for another 20 years. So this will be kind of your last opportunity for 2 decades if you want to see it within kind of the contiguous U.S. But eclipses will occur elsewhere, and you know, most often it will be over the ocean, just because the Earth has more water than land. But yeah, we do have total solar eclipses. Now, one thing that I will add, though, is the moon is slowly moving away from the Earth, very slowly, which means kind of many years from now, there won't be total solar eclipses at Earth once the moon is far enough away that it can't completely block out the sun. So it's really special right now that we're able to enjoy this, but that change will not take place in our lifetime. It will be quite some time until it actually happens.
That is a very fun fact. That was actually, you know, we have Stephen Papa on YouTube who wanted to know, does that mean in the far future, will eclipses be much different? And so, like you're saying, there's a day and age where we won't have these at all anymore.
Right.
So we are really here during the right time, the
Yes.
right moment to witness
Yes.
something like this all together.
Yeah, and I mean the moon, it's moving at like centimeters per year away. So
Okay.
very, very slow
We
rate.
don't have to worry.
But
Okay.
if we were on Mars, for example, Mars has solar eclipses when its moons cross in between Mars and the sun. However, they're not as fascinating as our eclipses because they're not total. It almost looks like a transit of a planet moving across the sun
Because it
because
doesn't cover it.
it doesn't cover the sun completely. So you could just see the moon crossing, and you can almost think of it as an annular eclipse, but the ring is much bigger than what we see here.
So earlier in the show, you touched on Bailey's beads and these different types of things we might see during today's event. And we have another viewer that wants to know about these special features that only happen during a total solar eclipse. Can you, like the diamond ring effect, Bailey's beads, can you explain those for us?
Sure. So on the surface of the moon, you know, there are craters, there are peaks, there are valleys, and when these Bailey beads or diamond rings occur, that's where you see the light of the sun just kind of piercing through some of these surface features of the moon. And the sun just kind of peeks out in between the peaks and the valleys, so that you can get that shiny diamond ring effect. And that really helps us to understand kind of the topography of the moon. But the moon and the surface features have also been studied very well by NASA's Lunar Reconnaissance Orbiter mission. So it's fun to kind of see how we make these measurements with our missions, and then we can also study them during natural events like the eclipse.
And can you remind us, what's the difference between Bailey's beads and the diamond effect? Are those the same thing?
They're very similar, yeah.
Okay.
So the diamond ring effect is more of that kind of wow factor, that brighter shine, where Bailey's beads, you can see a few of them almost bubbling across the surface is what it looks like. So they're similar, and they're caused by similar effects, but kind of just a difference in their characteristics.
And we have Katie Fisher on Facebook who wants to know, will the total solar eclipse affect the tides?
So the total solar eclipse will not affect the tides. Really, that's going to be affected by the distance that the moon is from the Earth. So as I said, the moon is slowly moving away from the Earth centimeters every year. Now, over a greater time scale, that will affect the tides, but not during the total solar eclipse.
And our great team moderating earlier got us an answer. You mentioned how Parker Solar Probe
Oh, great. Okay.
on December 24th is going to make its closest approach to the sun at about 9 solar radii.
Yes.
That is 3.9 million miles.
There we go.
So,
Thank
yes,
you.
absolutely. And so our next question is from Leela Coles Avery on Facebook, who wants to know, can I look at this safely, a total solar eclipse, through a telescope from North Carolina?
Okay, so it depends on your location and if you're in the path of totality. So check out our Eclipse Explorer map to see what kind of coverage you'll get. If you have totality, then you can actually use your telescope to look at the sun without a filter. However, if you're in that partial eclipse, then you can use your telescope, but you just need to make sure that you have that path of totality. And so as you're looking at the map here showing the path of totality, North Carolina is going to get that partial eclipse. So just make sure that you have a proper filter on your telescope when you're viewing the eclipse.
Okay, and still in this same light of viewing, photographing the eclipse, we have a hat-wearing duck on YouTube who asks, would it damage my phone camera if I tried to take a time-lapse of the partial eclipse through eclipse glasses?
Okay, that is one technique that people use is actually, so you have your eclipse glasses that you can hold up to your eyes. Now, you can put that in front of your phone to safely
lay the
take
phone
a time
down,
lapse.
put the glasses on,
That's
and leave
what
it there?
I would recommend. Yeah, because the one thing you don't want to do is put your glasses onto your phone and then accidentally, still try to look at the sun when it's partial. So you can use those viewing glasses as a filter, but just be careful, anytime you're doing this.
Absolutely. And so sticking again, kind of focusing on this path of totality, we have James Finn on Facebook who asks, how dark does it actually get in the path of totality?
It's best described as a dusk feeling. You'll definitely see the change. I mean, it's not going to be completely nighttime because some of the sun's light will still be scattered around the moon and light up just a little bit of the atmosphere, but it gets pretty dark. It's pretty impressive. Darker than what we saw for the annular eclipse, that's for sure.
Now, for those of us who have not witnessed a total solar eclipse before, could you tell us about your experience seeing one for the first time?
My total solar eclipse, so I was in Nashville in 2017 with my family, and we were kind of off the beaten path in the middle of nowhere, so we got to really experience the nature effect, seeing the birds go to the trees, hearing the crickets come out. But I do remember once that totality occurred, we were all just kind of looking at the sky and kind of screaming and getting excited, oohing and eyeing. It's just something that until you experience it, it's really hard to imagine, but it's so great.
So it's different than looking at a photo of it or something like that.
Yes, because as we talked about earlier, it is kind of all the senses, right? So you're seeing the eclipse, but you're also hearing changes in nature. You're feeling the temperature drop and maybe the winds pick up a little bit. In fact, during the 2017 eclipse, in my experience, we had some clouds start to cover the sky just before totality. And then as soon as totality hit, those clouds dissipated and went away. So we got to see the changes on the atmosphere with our eyes as well.
And we covered this a little bit before, but can you tell us about some of the experiments that NASA is running and can only run during a total solar eclipse?
Yes. So let's talk about the sounding rockets. That's actually something that we haven't hit on yet. So we have 3 sounding rockets that will be launching from our Wallops Flight Facility, which is in Chincoteague, Virginia. And these 3 rockets will be launching. One will take off 35 minutes before totality. One will take off during totality, and then finally 35 minutes after. And what we're trying to study here is basically measuring directly the changes in the upper atmosphere where the rockets are going to reach. And we're doing it before, during, and after so we can see the change kind of in how it propagates. Now, where these rockets are launching, it's not actually going to be within the path, but as the moon and its shadow, as the shadow of the moon is moving across that path, it's having changes in the local atmosphere, and they kind of propagate out, almost like a boat going through the water and making a wave. Yeah, it's kind of the same thing. So we're trying to see how those changes propagate out in the atmosphere.
So we've got a plane.
Yep.
We've got rockets.
We've got rockets.
Is there any other, instrument that NASA is planning to use to study the solar eclipse? I know last year for the annular we had balloons. Is there anything like that?
There are balloon projects, in fact, led by various schools. We have a ton of balloons that will be launching, science balloons measuring all over. And so that's something that you see on the screen here. Some of the students getting ready for those balloon experiments. There's also radio telescopes in California that will be kind of measuring those radio waves coming from the sun, because any active regions that are occurring on the sun at that time, they're going to be covered up by the moon. So as the radio telescope is just looking at the sun and these active regions are covered, we can see it's turning them on and off. So we can see where the waves are coming from and where they aren't, so to understand what the sources are, basically.
So we're studying this from, every single angle.
Everything that we can possibly do. Yes.
That is great. So our next question is from Happy Thumbs Gaming on YouTube, who wants to know, for the solar eclipse, will all of the United States be able to view it?
All of the 48 contiguous states will view some sort of eclipse. If you're in the path of totality, you'll have the opportunity to view that total solar eclipse. If you're not in the path of totality, then that's where you'll see a partial eclipse. So as long as you're within those contiguous 48 states, then yes, you can see it.
And you hit on this a little bit earlier, but why does this eclipse have totality for such a longer duration? You mentioned that this year is almost double from 2017.
Right.
Why is that?
Right. The moon's orbit actually isn't circular around the sun. It's elliptical. So it all depends on where the moon is in its orbit and really how close the moon is or how far it is from the Earth. And so for this one, compared to 2017, we're going to get that shadow just cast a little bit. The path will be a little bit wider. The shadow is going to really make that eclipse last a little bit longer just based on where the Earth is with respect to the sun.
And Bert on YouTube, who wants to know, being so close to the equinox, why is the path of totality at such an angle with the equator?
Yeah, so it depends. The moon's orbit is tilted by 5 degrees. And of course, with Earth, we have seasons as well. So there's kind of this game that you have to play between, the orbit, right, of the Earth and the moon and how the Earth is tilted, how the moon's orbit is tilted. And it changes kind of the geometry of where the eclipse occurs and how long and everything.
So earlier, we spoke a little bit about photographing a total eclipse with a cell phone. Now we have a viewer on YouTube who wants to know if pointing a telescope to the sun will damage the telescope during this event.
Right. We have filters for telescopes as well, solar filters that you put on your telescope so that you can safely view the eclipse. So that's what I would recommend, especially if you're in that partial eclipse area. Now for the total eclipse, that's when with our own eyes, we don't need to have the glasses on and you don't need to have a filter for your eclipse. But it also depends on what you're trying to see. If you're trying to see that corona in a certain light, you might want a filter for that too, that allows you to take different types of images and different science as well.
Okay. For those just joining us, we have another question from Scientific Potato on YouTube who wants to know, will animals under the total solar eclipse be acting weird?
They will be, yes. Nature changes during the eclipses. It gets confused. Nature basically thinks that the sun is setting and that it's nighttime, and that's where we kind of have animals getting ready to go to sleep, birds going to the trees, crickets that come out and chirp. So that is part of the whole eclipse viewing experience, is to really kind of see and hear nature around you as well.
You mentioned something too, I remember from the annular eclipse, something about spiders and their webs.
Oh, there is something with spiders. I can't remember it off the top of my head, but I think it has to do with, their spiders coming up and their webs coming up and down too. That's right.
And so our next question is actually from a viewer on YouTube who wants to know, what advice do you have for anybody who might be experiencing this solar eclipse for the first time?
I love this question. I would say really take a moment to embrace it and, experience it with as few distractions as possible. I mean, I know that we're all excited to take pictures of the eclipse to be able to share the experience. We're lucky that totality lasts for 4.5 minutes because you can, have a few moments of quiet to kind of see and feel and look around, but then you can also take the photo that you want as well. So I would just say, make sure you put down all your things and try to enjoy it. Yeah, exactly.
Well, Gina, unfortunately, that is all the time that we have for today.
Okay.
But thank you so much for just joining us and for answering so many questions from our viewers. I am so excited to be sharing NASA's stage in Kerrville, Texas with you in just a few weeks.
Yeah, thanks to Hira. It was great being here today, and I'm really looking forward to our broadcast in Kerrville.
And thank you to everyone who joined us online. We had some fantastic questions today and really love getting to engage with you live like this. We hope you enjoyed learning more about the total solar eclipse and feel better prepared for the upcoming event. Now make sure you set a reminder to join us on April 8th. We will be streaming the eclipse live from all over North America, following that path of totality as it sweeps across Mexico, the U.S., and Canada. There are a variety of ways for you to get involved. You can watch the NASA broadcast on multiple streaming platforms, including in Spanish, by heading over to go.nasa.gov/eclipse 2024 live. You can also take a look at NASA's website to see if there are eclipse events near you at go.nasa.gov/eclipse events. If you'd like to stay updated on all of the latest sun news, follow NASA Sun on Facebook and NASA Sun on X. Thank you, and see you next time.
We are one of 100 billion stars in a vast galaxy, but for all of human culture on Earth, one sun that nourishes us all.
That is what stirs humankind. That's what unites us.